Okay, good morning, everyone. It's nice to see you, sort of, on this April Fool's Day. Unfortunately, things are not too humorous at this time, but I hope that you and your families are doing okay. Try not to watch the news too much because it's very depressing at this time. So, if you can hear me okay, would you please type in yes into the chat window? Okay, thank you very much. All right. So, gang, today we are 2 weeks away from your next lecture exam 2, and that is scheduled to be on April 15th. Okay, 2 weeks from today is April 15th. And so normally what I do is spend some time giving you a study guide in class, but because not everyone is able to attend our meetings. Right now, we only have about 14 people in the meeting, so only about half of our class is with us today. What I'm going to do is type up a study guide for you and expect that you will get it later today in an email from me. And it will be a typical study guide where I give you a list of vocab-related terms that gives you some suggestions about vocab terms that are important for you to understand and their associated concepts. And I'll also give you hints about the essays that are going to be on your next exam. So please look for that in this afternoon's email from me. Excuse me. At this time, do you have any questions or concerns about the course, about any of the testing schedule? You know that, so we're going to have a lecture exam in 2 weeks, and you know this coming Monday, you're going to have your second lab exam. The second lab exam is on muscle identification and tissue identification from the histology pack that was sent out to you a little bit ago. Do you have any questions at this time? Okay, I'm not hearing anything from you, so I hope everything's okay. If you do need help, you know, please reach out, send me an email with concerns and questions, or during our time here together, or during the virtual office hour at around 9:30. Please, please stick around and ask for the help that you need. Okay, gang. What we're going to do is finish up some quick notes from chapter 9 on the angular motion terms. I want to be sure that they're in your notes, and then we will start chapter 10 today. Okay, so bear with me one moment while I start sharing my screen with you so that you can see the Microsoft Word document. Okay, so at this moment, you should be seeing the Microsoft Word document. And I put up the last notes from our last class. We were just getting started defining some of these angular motion terms. Remember that the angular motion terms describe scenarios where there is a significant change, either an increase or decrease in the angle of the bones that are articulating with each other. So right now, I'm simply going to put into your notes a bunch of definitions of the terms you see on pages 267, 268, and 269, and 270 of your textbook. Okay? All right, so continuing forward here. Nicole has a question, are all angular motions between bones? Yes, at this moment in the conversation, these terms are meant to describe the relationship between bones that are moving, yes. Okay. All right, so flexion was the first term we put in your notes last time, and it describes a decrease in the angle between articulating bones. If you were to bend your elbow so that your palms came forward towards your face, if your arms were out in front of you and you moved your palms towards your face by flexing your elbow, that would be an example of flexion. If we do the opposite, where the palms of your hand are already at your face and you move them away from your face, that is extension. So extension is an increase in the angle between articulating bones. Okay. All right, normally in class, this is much more enjoyable to do because I try to actually demonstrate these motions to you and then get you up out of your seat so you do them for yourselves. It's a little hard to do that right now, but we'll do the best we can. Okay, next motion would be lateral flexion. Lateral flexion. Okay, lateral flexion looks like the guy in the bottom right corner of page 267. This is the movement of your trunk sideways from right to left or vice versa. Movement of the trunk sideways from right to left or vice versa. Okay. Next we have hyperextension. Okay, hyperextension is continuation of the extension motion beyond the anatomical position. Okay. Okay, obviously that hyperextension is often associated with a variety of different injuries. Okay, if you look at the knee joint picture, page 267, and notice what extension looks like when you straighten out your lower leg, okay? When you do that, if you were to continue that motion in an unnatural way, you can see how it would damage your knee joint. That would be an example of hyperextension. Hyperextension is continuation of extension beyond the healthy, normal anatomical position. Okay. Next we have abduction and adduction, kind of like two sides of the same coin. Abduction is the movement of a bone away from the midline. Okay, let's see here. We should have a picture of this. Yeah, figure 9.6, page 268, shows you a gentleman that's performing both abduction and adduction. Okay, movement of a bone away from the midline. And the opposite motion is adduction with two D's, A-D-D-U-C-T-I-O-N. Movement of a, excuse me, I should have had bone up there. Movement of a bone toward the midline, okay? So, usually when I think about abduction and adduction, I think about the times when I was a kid where it was snowing outside and I'd go out and play in the snow and I'd lay down in the snow and I knew I would move my arms and legs in a similar motion to you see on figure 9.6 and I would create a snow angel, right? If you're moving your arms away from the midline to make the wings of a snow angel, that's abduction. If you're bringing your arms back towards your midline to continue to smooth out the wings of the angel, that's adduction. So however you need to keep it in your mind, go ahead and do that. That's how I do it. I think of the abduction and adduction as the motions you need to perform to create a snow angel. All right. Continuing forward, please feel free to type in questions into the chat window if you have them, or to unmute your microphone if you have a comment. Okay, next would be circumduction. Okay, Circumduction is shown to you on figure 9.7 on page 269. In circumduction, you have the movement of the distal end of a body in a circle. Okay, and so you can see that person's leg on picture B there moving in a 360-degree motion, a circular motion. That would be an example of circumduction. Okay, next we have rotation. Okay, rotation, is exactly what it looks like on figure 9.8, page 269, where that woman is actually moving her head from left to right. As you move your head to look to the left, as you move your head to look to the right, that would be an example of rotation. Rotation is when a bone revolves around its own longitudinal axis. Okay. And then we also have a variety of what your textbook describes as special movements that I also want to put into your notes. I'm just going to include them with our list here so you have them all together organized in your notebook. We have elevation. Okay, elevation is a superior motion, meaning when you're moving in a superior direction. Okay. When you look at picture A on page 270, you see elevation contrasted with depression. Okay, so elevation is a superior motion. And an example of that would be when you're raising your mandible to close your mouth. Okay, so the opposite of elevation is depression. Again, you can see that on figure 9.9, page 270. And then depression, you have an inferior motion, okay? Such as when you lower the mandible to open your mouth. You have to play whatever little tricks in your own mind you need to remember things. When I think about depression, depression in the context of our conversation, an inferior motion, such as when you lower your mandible to open your mouth, I think about how depressed I get when a politician opens his or her mouth to say something. Okay, so that's how I remember it. Let's continue. Next one would be protraction. Okay, protraction is movement of a body part anteriorly in the transverse plane. Okay, so if you look at picture C and picture D on figure 9.9, you can see protraction where you kind of move the head forward, and retraction when you return from that motion. It's almost like a chicken head motion. If you can imagine a chicken pointing its head forward and then coming back towards its normal body position, that would be protraction and retraction. Protraction is the movement of a body part anteriorly in the transverse plane, and the return from protraction is retraction. Okay, the return of a body part from a protracted position. Okay, so think of protraction and retraction as the, chicken head motion, or, the old song "Walk Like an Egyptian." If you've ever seen the video of that, you have people walking around sticking their heads forward and then bringing them back towards their normal body position. Okay, so the chicken head motion. Okay. Mosina, is your question about protraction and retraction? Is it like walking forward or backward? The answer, okay. No, it is not. It is not. In protraction and retraction, only part of the body is moving forward and the rest of it's staying back. Okay, so if you sit comfortably in your chair with your back straight and your head straight, and then you use your neck and extend your head forward, that would be protraction. It feels a little uncomfortable. Then if you bring it back so your head is normally aligned with your vertebra again, that would be retraction. So the answer to Mosina's question is no. Okay. Let's continue here. Next one is dorsiflexion. Okay, dorsiflexion. Let's see here. Dorsiflexion and plantar flexion are illustrated on picture G of figure 9.9. And if I could spell properly, that would help. Okay, dorsiflexion is bending the foot upward at the ankle so that you're standing on your heel, on the heel of your foot. Okay. The opposite of that is the plantar flexion, which is bending the foot downward at the ankle, so you're actually standing on your tippy toes. Okay. All right, next we have pronation and supination. Okay. Let me see here if we have a good picture of that in your book. Okay, they do show you a picture in the book. And that would be letter H on figure 9.9, page 270. Okay, let me get these in your notes here. Okay. So we have pronation. This is a movement. Let me see how I want to define this for you. This is a movement. Let me give it to you as a definition in relation to your forearm. Pronation is when you turn the palms of your hands posterior. Motion that ends in the palms of your hands being in a posterior position. Now remember, our starting point for these motions is always anatomical position. So if you're standing in anatomical position with your arms down by the side of your body, your palms are facing towards the front of your body. Your palms are facing forward. If you rotate the palms of your hand so that the thumbs of your hand move towards your midline and your palms finish back behind you so that the palms are positioned posteriorly, that would be an example of pronation. Okay, the opposite motion of that is in fact supination. This is the motion such the palms of the hand finish or end up in an anterior position. Okay. All right. And then finally, I think the last thing that I want to put into your notes is the term opposition. Okay, so there's quite a lot of these special terms. Okay, in the context of our conversation here of angular motion, opposition refers to the movement of the thumb to touch your fingertips. Okay, so if you move your thumb on your hand to touch your fingertips, that would be called opposition. Okay. All right, gang. So now I know that I have these notes in your notebook. I've given you these terms. Okay, table 9.1 on page 271 also does a nice summary of some of these major terms. But I want to encourage you during your personal study time to actually, get up out of your seat and try some of these motions on your own. Try to mimic some of the motions of the pictures you see on pages 267, 268, 269, 270. What I'm saying is, you're home. Nobody's going to see you except your own family. Okay. So try moving the body and feeling what these motions feel like when you do that. So let's do a little silly activity right now. Now that we have these terms listed in your notes, let's do a little silly activity right now where we try to do some of these motions here together in class. It's not going to be as fun because you're not going to be able to look each other and laugh at each other as you try to do this. It's usually fairly comical when we do this in class together, so I wish we were together. But if you would, please humor me here, and please stand up wherever you are in your home or wherever you're taking notes at this time. Stand up in front of your computer. Nobody sees you right now. I mean, I can't see you. So, you're doing this on your own. And what I'd like you to do is start an anatomical position. Okay, so I'm going to stop my screen at this time so that you can see me on the video screen. Okay, I'm going to stop sharing here. So you hopefully can see me at this time on your video screen, on your computer screen. And I'm going to try to move my chair aside so that you can see me. So for our time together, we always want to start in anatomical position, which means you're kind of positioned like this, okay, with your palms facing forward and you're standing straight, okay? Now, as you're doing this, okay, you might want to position yourself in a comfortable way so that you don't hit any furniture or something like this. And also, you want to be close enough to a piece of furniture so that you don't accidentally lose balance and fall over, okay? But okay, at this time, starting from anatomical position, I would like you to hyperextend your right hip. Hyperextend your right hip. Okay, so unfortunately, I can't really do it in a way that you can see it on the video screen because I just don't have enough space behind me to do it. But try to hyperextend your right hip at this time. Okay, so your right leg at the hip should be pointing back away from you. Now, while you're in that hyperextended state with the right hip, try to simultaneously flex the right knee. So you want a hyperextended right hip, and at the same time, flex the right knee. You should definitely be feeling the muscles stretch at this motion. Okay, with your right hip hyperextended and your right knee flexed, I want you to also do the following thing. I want you to plantar flex your right ankle. Plantar flex your right ankle. Okay, so at this point, the toes of your foot should be pointed like a gymnast doing a gymnastic routine. Okay, so hopefully you're laughing at yourself at this time. Go ahead and relax and go back to the anatomical position. Go back to anatomical position. Okay, start in anatomical position. And what I'd like you to do at this time is to flex your elbows 90 degrees. Okay, so hopefully you can see me on the computer screen. I have flexed my elbows 90 degrees. I want you to do that. Next, I want you in this position to pronate your palms. So from here, pronation would mean you rotate the palms so that the palms are facing down towards the floor. And now what I want you to do is abduct your fingers. Okay, if you think of the midline of your hand, you want to separate your fingers. As it looks on page 268, picture D of 9.6, so figure 9.6. Okay, so we have the palms of our hand down and we have our fingers splayed open. Okay, relax from that and start and get back into anatomical position. Okay, the next thing I would like you to do is to flex your left knee. Flex your left knee. Now, what I often see in folks when they flex their left knee is that they actually move their left hip forward. And you don't want to do that, right? We're not talking about moving the hip joint at this time. We only want you to move the knee joint. So be very careful that you're flexing your left knee, but you're not moving your left hip. So as you're flexing the left knee, now I want you to flex the left hip. So flex the left knee and the left hip at the same time. Okay, so your thigh should be in front of you at this moment. And from here, I want you to dorsey flex your left ankle. So your toes at this point should be pointing up towards the ceiling. So we have our left knee flexed, our left hip flexed, and you're dorsey flexing your ankle so your toes are pointing towards the ceiling. Now, and this is better in class because you're standing next to each other, I want you to extend your left knee. So if somebody was in front of you, you would give them a swift kick in the behind. Okay, go ahead, relax, go back to anatomical position. Let's do one more of these. What I'd like you to do at this time is to adduct, A-D-D, adduct your shoulder blades. I want you to adduct your shoulder blades. Okay, adduct means you move the body part towards the midline of your body. So I want you to think about that. In this case, adduct means you're going to move your shoulder blades towards your midline, and as you do that, your chest is going to push forward. So just feel that. Okay, so we're adducting our shoulder blades. Now what I want you to do at this moment, as your shoulder blades are adducted, your chest is pushed forward, I want you to protract your head. Okay, so you're shoulder blades are forward, you're protracting your head forward. You can really feel the muscles in the back, the shoulder region, and the neck stretching. Now, as your head is protracted forward, I want you to protract your mandible. I want you to protract your mandible, meaning your head's forward. Now I want you to push your lower jaw forward. Okay, you probably look very weird at this moment. So with your jaw protracted, the mandible protracted, I now want you to depress the mandible. I want you to lower it and open the mouth. So you should look really weird at this time to anybody sitting near you in your room, your family members. You can feel all those muscles stretching. Okay. All right, gang. Relax. Okay, relax. And to finish this out, I simply want you to circumduct your shoulders posteriorly. So roll your shoulders, work out that tension from stretching the muscles. Okay, circumduct the shoulders and go ahead and have a seat again. All right. So, you know, this material is a little cut and dry, but it does have important value for those that are going to be involved in physical therapy if you're going to have a career in physical therapy. So, you know, try to actually do the motions at home while you're studying, you know, by yourself, you know, and stand in front of a mirror and try to do the motions and literally feel the motions of your muscles and bones as they're moving. Okay, Lindsay, what happens when someone has hypermobility syndrome? Usually when you have hypermobility syndrome, you have a problem with a joint. And what I mean by that is you might have ligaments, excuse me. You might have ligaments that are positioned incorrectly between the two bones, which allows for excessive motion of the bones. You might have ligaments that are positioned at the wrong point, or ligaments that are unnaturally or on average are longer than they're supposed to be. And so that's what allows for that hypermobility problems. And obviously that can cause bones to move out of alignment with each other. Okay, other questions? Okay, gang. So we're going to let chapter 9 rest at this time and start moving into chapter 10, which is the muscle anatomy and physiology. Okay. So bear with me just a moment while I bring up the Word document again. Okay. Chapter 10. All right. Chapter 10, if I'm not mistaken, is the last chapter that will be on lecture exam 2 in 2 weeks. Okay. So this is the last content that you have to be ready to test on in 2 weeks. It's on muscle tissue, both on the microanatomy of the muscle tissue as well as the physiology of muscle contraction. So we're going to be spending at least another 2 class periods on this topic. Okay, so in lab, you are responsible for being able to identify muscles, okay, at a large macroscopic level, that you know where the biceps brachii is. In this chapter and on your lecture exam, I'm not going to ask you to identify the biceps brachii, but I might ask you to tell me something about the physiology of how that biceps brachii contracts, or might expect you to know something about the cellular anatomy of the muscle cells that make up the biceps brachii. Okay, let's continue. So just some starting points, starting comments. Okay, first, the term myology. Myology is the scientific study of tissue, scientific study of muscles. Let me bring up the chat window again so that I know that you can reach me if you need me. Okay, myology is the scientific study of muscles. Number two, the function of muscle tissue is to transform chemical energy into mechanical energy. Okay. When a muscle does this, when it achieves its goal of transforming chemical energy into mechanical energy, then the muscle is able to generate some sort of force. And that force then allows the muscle to do work, which in most cases means produce movement. I mean, think about the motion that your arm and hand muscles are allowing you to do so you can write notes or type onto your computer keyboard to put the notes into digital form. Okay. When successful, muscles are able to generate force to perform work, such as moving a body part. Okay. All right. All right, let's talk about the types or categories of muscle tissue. This is not a surprise to you. You're experts from studying chapter 4, and you know from your histology pack, you already know the 3 major types of muscle tissue that exist. Okay, so we're not telling you anything new here. Categories of muscle tissue. First, we have skeletal, and that's basically what you're responsible for on the lab exam, right? Skeletal muscles. Most skeletal muscles move bones of the skeleton. There are some exceptions to that. For example, your tongue is a skeletal muscle, and the tongue is not moving a bone. We also have things like the diaphragm, which is important for your ability to ventilate the body and breathe, and that's not moving a bone. But by and large, most skeletal muscles move bones of the skeleton. Okay, now some features of skeletal muscle tissue. Skeletal muscle tissue is in fact striated. Okay, that means it has stripes. Striated is sort of a fancy word that means that there are stripes present. And let me see if I can find a good image of that. Well, let's see here. Not quite seeing what I want to see. Let me check chapter 4 very quickly here. Yeah, okay. If you turn back in your textbook to page 136, picture A in table 4.9 is an example of the skeletal muscle tissue, and your book points out the striations. On that picture, the striations are horizontal, they're moving left to right. So skeletal muscle tissue is striated, and if you look carefully at picture B, the cardiac muscle tissue, which we'll put in your notes in just a moment, you'll notice it's also striated. So skeletal muscle tissue and cardiac muscle tissue are both striated, and those striations are due to the arrangement of proteins in the muscle cells themselves. Okay. Most skeletal muscle tissue is voluntary, which means that your brain can consciously control it, right? You think about how your brain is controlling your fingers to write notes at this time, or how your brain is controlling your leg to reshift your body position in some way. You are thinking it, and your body is executing your thoughts. So most skeletal muscle is voluntary, but there are exceptions, like the diaphragm. Okay, the diaphragm, as you recall and as you know from your time in lab study, the diaphragm is the muscle that separates the thoracic from abdominal cavities. It's very, very important for your ability to breathe. Okay, you can consciously control it a little bit, right? You can hold your breath for a while and stop your breathing, but that will only last for so long, maybe a minute or something, before your brain will override your conscious thoughts and compel your body to start breathing again. Okay. Now, skeletal muscle physiology, how it functions and what it does when it does it, is influenced by both the nervous system and the endocrine systems. Skeletal muscle physiology is influenced by the nervous and endocrine systems. Gang, you're going to get the nervous system at the end of our course here, and it's something new for this semester with you AMP1 students. The endocrine system you're going to get in AMP2. Okay, please ask questions as you have them. Please feel free to type into the chat window. Next, we have the cardiac muscle tissue. Okay, cardiac muscle tissue forms most of the heart wall. Cardiac muscle tissue is also striated like the skeletal muscle tissue, but the action of the cardiac muscle tissue is involuntary, right? You cannot consciously control your heart contraction. Okay, cardiac muscle tissue is also striated, but the action of the tissue is involuntary. Okay. Letter B. Cardiac muscle tissue. With cardiac muscle tissue, the heart beats automatically because of specialized group of cells, primarily in the right atrium, called the pacemaker. Okay. Your group is the first group in AMP1 not to have the cardiovascular system taught. Cardiovascular system has now been moved to AMP2. So you will get cardiovascular knowledge in AMP2. The heart beats automatically because of pacemaker cells in the right atrium. Okay. The pacemaker cells are actually part of what's called the sinoatrial node. And you'll learn more about that in AMP2. Okay. your heart can beat all by itself without any external stimulation. Your heart can beat all by itself without external stimulation, but the nervous system and hormones can influence that heart contraction rhythm, okay? The heart can beat by itself without external stimulation, but is influenced by the nervous and endocrine systems. Pam has a question. When people get a pacemaker placement, it's because the cells are not working properly. Yes, Pam, that is true. Okay. You actually have two groups of pacemaker cells. You have sinoatrial cells in the right atrium, and then you also have the atrioventricular cells that are lower to that. So you actually have multiple pacemakers in the heart, and generally speaking, when you get a pacemaker replacement, it's because one of those clusters of cells has malfunctioned or become damaged through disease. Okay. Number 3, we have smooth muscle tissue. Smooth muscle tissue is found in the walls of hollow internal structures such as blood vessels. Okay, another question from Jennifer. What happens after you get a heart transplant? Do you still need a pacemaker? No, not typically. When you get a heart transplant, the heart itself, the new heart that's being put into your body, contains the biologically correct version of the pacemaker. You don't typically need an electronic version. So no, you don't need a pacemaker with a heart transplant. Okay. Let's see. Smooth muscle tissue is also found in the skin. And I won't take you back to it, but if you go back to our skin chapter and look at the structure of the skin, you'll notice that there's smooth muscle tissue attached to the hair follicles. Okay, so the point I'm trying to make is that we have smooth muscle tissue in areas that you may not typically think about. Okay. Smooth muscle tissue is not striated, and that's the reason it's called smooth, which is why smooth muscle tissue is called smooth. Okay, most smooth muscle tissue of the body is involuntary. Okay, and just like the first two categories of skeletal and cardiac muscle tissue, smooth muscle tissue can be influenced by hormones of the endocrine system and neurotransmitters of the nervous system. Okay, gang, any questions about the basic varieties or categories of muscle tissue? Skeletal muscle, cardiac, and smooth muscle. Okay, let's take and put down the properties of muscle tissue. Properties of muscle tissue. Okay, all muscle tissue is electrically excitable. Okay, so what that means is that neurons of the nervous system have the ability to electrically stimulate, electrically excite, electrically agitate all forms of muscle tissue. Okay, when we're talking about properties of muscle tissue, this refers to all three categories. All three categories of muscle tissue. Okay, nerve cells can electrically stimulate muscle cells. Okay, one of the things that you will learn at the end of our semester is about this phenomenon in the nervous system called a nerve impulse. A nerve impulse is an electrical signal. Well, long story short, and I'll give you more detail at a later time, muscle cells can be excited by these nerve impulses, and then the muscle cell responds by creating its own version of an electrical signal called a muscle impulse. Okay. Number two, muscle tissue has contractility. And what that means is that muscles have the ability to forcefully shorten. Okay. Number three, muscles exhibit what's called extensibility. And that simply is a fancy way of saying that muscle cells and the muscle tissue itself has the ability to stretch. And number four, okay, if muscle tissue can contract, which means to shorten, and it can also stretch, the extensibility feature we just put down, if it can contract and stretch and go back and forth between those two states, that means that all muscle tissue has elasticity. Muscles can shorten and lengthen cyclically. Okay? Muscles can shorten and lengthen cyclically. They are elastic. So just like a rubber band, you can stretch them out, and when you stop stretching the rubber band, it returns to its normal length. You can do that repeatedly with muscle tissue. Okay, a question from Pam on the chat window. So muscles are excitable because they respond to a stimulus from the nervous system, right? Like an action potential? Yes, Pam, that is true. Okay. All right, gang. So let's take a look. Our next talking point here is going to be the connective tissue that's associated with skeletal muscle tissue. So for the rest of our conversation at this point, we're going to primarily focus on skeletal muscles, because in other areas of the course and in AMP2, you're going to get information specifically for the heart and the cardiovascular system. Okay, so we're going to spend most of our remainder time in chapter 10 talking about skeletal muscle. So the next topic is connective tissue that's associated with skeletal muscle tissue. And let me highlight first something that I want to be sure that you appreciate, and that is that there are different ways of referring to a muscle cell. So simply remember that a muscle cell is the same thing as a muscle fiber, and a muscle fiber equals, it is the same thing as a myocyte. So muscle cell, muscle fiber, and myocyte are three ways of saying the same thing. They are synonyms. Okay. Also remember the term fascia, F-A-S-C-I-A. Okay, this refers to sheets of irregular connective tissue that line the body walls and surround muscles and other organs. Fascia refers to sheets of irregular connective tissue that line body walls and surround muscles and other organs. And of course, the point that we're making right now is that we need to be aware that connective tissue called fascicles, called fascia surrounds muscles. Okay, so you may want to be looking at figure 10.1 at this time. Okay, figure 10.1. And I want to point out some layers of these fascia that surround various aspects of the muscle tissue. Okay, so within figure 10.1, let me point out the epimysium. Epimysium, okay? As you look along the right side of the page on page 296, you can see the word epimysium, and it's actually written several times along the right side because they're highlighting it from different viewing aspects and viewing angles, if you will. Okay, so try to put your eyeball on these structures in your textbook. Epimysium is the outermost layer of dense irregular connective tissue that encircles the entire muscle. Okay, the outermost layer of dense irregular connective tissue that encircles the entire muscle. Okay. Now, if we go internal to a muscle, what we're going to find are groups of muscle cells that are called fascicles. Okay. These groups of muscle cells that are called fascicles actually have their own layer of additional connective tissue, their own fascia that wraps around each group of muscle cells that we call fascia. And this layer of connective tissue is called the perimysium. So the perimysium is the layer of dense irregular connective tissue that surrounds groups of muscle cells called fascicles. Okay? If you've ever made beef jerky or anything like that, and you've taken a piece of beef of some kind and you've sort of torn it, if you will, if you tear a piece of meat to make beef jerky, to make strips of meat, if you will, typically the tissue will tear along the fascicles of the tissue. All right, so please put an eyeball on the perimysium. The perimysium is wrapped around groups of muscle cells that are called fascicles. And then the third and most internal structure is the endomysium. Okay, the endomysium is the layer of dense irregular connective tissue that separates individual muscle cells. It surrounds individual muscle cells. Okay. Now, please note that all of these layers of fascia touch other layers of fascia. The endomysium, at various moments, is physically stitched to the perimysium, and then the perimysium is physically stitched to the epimysium. Okay, so they are continuous with each other at different locations of their structures. All right. Questions at this time? Okay, so what I'd like to do is put a flow chart in your notes at this time, which can help highlight how muscles contract and how that contraction of muscle cells allows the connective tissue, including the fascia that we just described, to actually move a bone. For example, when we were doing the funny little work this morning and I was having you do the angular motion, exactly how is it that, what actually has to happen when you contract your biceps brachii to bend your elbow joint so that the palms of your hand can move towards your face? Exactly what's the sequence of events that's going to occur here? Well, we're going to be going over this again and again and again, but let me give you a starting point to think about this. So here is a flow chart which discusses the pathway between muscle contraction and bone movement. And this flow chart may have some new terms in it that you're not used to yet. Don't worry about that. We're going to get you through it. Okay. So I know I haven't talked in great detail yet about something called a sarcomere, but that's where the flow chart starts. Okay, we'll talk about sarcomeres in just a second. So the very first thing when a muscle contracts is that a sarcomere will shorten. If you want to take a quick look at what a sarcomere looks like, you can take a look at page 299 of your textbook and see the picture there. And you can see in the middle of that picture, you see a black bracket with the term sarcomere. Okay? We'll be talking about that in more detail pretty soon. Okay, so for the muscles to contract, these things called a sarcomere have to shorten. When they shorten, they cause the myofibril to shorten. Myofibril shortens. Okay? Now, the myofibril is, well, let's see here. If you're still looking at the picture on page 299, and you see where the sarcomere term is, you notice that the sarcomere is repeated along that piece of cylindrical cellular anatomy there. That entire cylindrical tube, which includes the sarcomere, is in fact the myofibril. Okay? So the sarcomere shortens, which causes the myofibril to shorten. Okay, when that happens, the myofibril pulls on the sarcolemma of the muscle cell. Okay, now the sarcolemma is another new word. The sarcolemma is the plasma membrane of the muscle cell. Okay, so when the myofibril shortens, the sarcolemma begins to pull inward. Okay, so when the sarcomere shortens, the myofibril shortens, the sarcolemma begins to pull inward. And you notice that's achievable because on the picture on page 299, the myofibril is attached to the sarcolemma by what protein? You tell me in the chat window. What protein connects, putting a question in the chat window now, what protein connects the sarcolemma to the myofibril? Take a good look at that picture on page 299. What protein is a bridge between the myofibril and the sarcolemma? Okay, good. I'm getting some right answers. That is the correct answer, dystrophin. Okay? So when the sarcomere shortens, the myofibril shortens. And as the myofibril shortens, because the myofibril is connected to dystrophin and dystrophin is connected to the sarcolemma begins to pull inward. In other words, the muscle cell itself begins to contract. Good job. Okay. So next, when the muscle cell begins to shorten, you can appreciate that the muscle cell is going to tug on the fascia that is around the muscle cells, and the name of the fascia around individual muscle cells is the endomysium. Okay, so the sarcolemma begins to pull inward. This tugs on the endomysium. Okay, tugs on the fascia that surrounds the muscle cell, and because the sarcolemma is stitched to the endomysium, when the sarcolemma moves, so does the endomysium. Now, as we mentioned, the endomysium is tethered to the fascia that separates groups of muscle cells called fascicles. That layer of fascia is called the perimysium. So when you tug on the endomysium, you then tug on the perimysium. So you can see how this is happening here. Imagine that we have a tug of war team where we have one person holding on to the person in front of them, and that person is holding on to the person in front of them, and that person is holding on to the person in front of them. If the person at the back of the chain pulls, then as long as nobody lets go of their grip, everybody's going to get pulled along at the same time. So when we tug on the perimysium, we now tug on the layer of fascia around the entire muscle, which is the epimysium. So you tug on the epimysium. And what may or may not be clear to you by looking at figure 10.1 on page 296, is that the epimysium runs into the tendon that is attached to the bone. So when you tug on the epimysium, the next thing you tug on is the tendon. Tug on a tendon attached to a bone. And you know that muscles are connected to the bones via the tendons. So this is kind of how all this molecular anatomy is connected together to allow that to work. So you tug on the tendon in number 6. The tendon is connected to a special membrane that covers the surface of compact bone. What's the name of that special membrane? What membrane covers compact bone? Okay, thank you, Chris. Okay. Oh, yeah, okay, Jennifer, thank you. I have a typo in my notes. Why are there 2 number 5s? There should not be 2 number 5s. Let me fix that. Yes, okay. Thank you, Jennifer. And yes, Chris is correct. The name of the special membrane that covers compact bone is the periosteum. So when we tug on the tendon, the next thing we tug on is the periosteum. And of course, the periosteum is literally stitched to the surface of the compact bone by what material? What material stitches the periosteum to the compact bone? What material stitches? The periosteum to compact bone? Can anybody answer that? Something we talked about before. What material stitches the periosteum to compact bone? Okay, thank you, Nicole. Perforating fibers. Okay, you have the right idea. They're not called perforating fibers. They're called Sharpey's fibers. Sharpey's fibers. Okay, but you have the right idea. Okay. So we tug on Sharpey's fibers, and that, of course, connects the periosteum to the surface of the compact bone. And so the very last thing we can realistically say is that the bone moves. Okay, so let me read that flow chart back to us. First, the sarcomere shortens, then the myofibril shortens. Then the sarcolemma shortens, meaning it pulls inward, which then tugs on the endomysium fascia, which then tugs on the paramysium fascia, which then tugs on the epimysium fascia, which then tugs on the tendon, which then tugs on the periosteum around the compact bone, which then tugs on the Sharpey's fibers, which connect the paramysium to the compact bone, which then literally tugs on the bone, and the bone moves. That's the series of molecular events, the molecular anatomical events that actually takes place. Okay. Who knew it was so complicated, right? But you get the idea. In this class, it's always complicated. But as you start to appreciate what these things are, it's pretty neat. It's pretty fascinating. Pretty amazing how your body's been constructed. Gang, do you have any questions right now? Okay. All right. I'm looking at my watch and I have 9:14. It doesn't make much sense to me to start another topic at this time because I won't be able to finish it. So folks, what we will do is take our pause at this time. I will be back online at 9:30 for office hours. For those that are wondering if it's worth staying online, please know that I will give out the answers to the lab homework, including the answers to the histology pack. Now that, of course, was put down in Monday's video as well, so you don't have to show up if you don't want to. However, I will also give a small practice quiz on the muscle exam that will happen this coming Monday. So if any of that is of interest to you, feel free to stick around and be part of that. Also, if you have other general questions about content or anything like that that I can help you with, I'll be happy to do that. So before we close for a very quick 15-minute break, do you have any questions at this time? Okay, not seeing anything, then gang, I will be back with us. We'll be back together if you want to at 9:30 to go over some of your homework. Question from Rosana, is the test example question the same as we did on Monday? Yes, it is. I won't be giving new images. It will be the same. Okay, anything else? Okay, gang, so remember, this Monday you have your lab exam. It will be taken through the Class Marker website, and the exam will open at 7 a.m. and generally it will stay open till midnight. So you can take it at any time during the day. But once you start the exam, you have to finish it. You can't start it, stop it, and go back to it. You have to take it in one seating. So make sure that you're ready to take it when you start the exam. Make sure you're free of distractions, and try to make sure that you have some food in your belly so you're not hungry while you're actually taking the exam, because that will hurt your score. Okay, folks, I will see you at 9:30 to provide some additional help. Otherwise, take care and be safe this weekend. See you soon. Okay, folks, welcome back. I'm assuming if you're sticking around that you are interested in getting some of the homework questions answered. But before I do that, let me ask you, are there any other questions you may have at this time? Anything you want help on? Okay. Okay, Brendan, I saw your message. Pam asks, are we doing the essays in the same website? So I assume you're talking about the lecture exam, Pam. Yes, the entire exam for, at this point moving forward, the lab exam, all of it is online, and lecture exams, all of it will be online. Okay, anything else you'd like to ask for the good of everybody? Okay, gang. So let's go through your homework, the lab homework. Due today was lab exercises 12, 14, and the histology packet. So let's do exercise 12 first. Please turn to your work for lab exercise 12, and we will take a look at reviewing your knowledge. And let me bring that open on my materials as well. Okay. Okay. So we will go over Okay, so Jennifer has asked the question, how will we be taking our lab test? Your lab test, Jennifer, is going to be taken online using the ClassMarker website. So an email was sent out some time ago for you to make an account on the ClassMarker website. If you don't know what I'm talking about, please send me an email so I can help you. But you use the ClassMarker website on Monday to take the exam, and you will be given 40 minutes to take the exam. Okay, gang, let's take a look at lab exercise 12, page 183, reviewing your knowledge. Letter A, skeletal muscle structure. Okay, gang, so you were supposed to arrange these from largest to smallest. Number 1 being the largest would be muscle. Number 2 would be fascicle. 3, muscle fiber. 4, myofibril. And 5, filaments. Section B, skeletal muscle structural terms. Number 1 is perimysium. 2 is T-tubule. 3 is sarcolemma. 4 is epimysium. 5 is sarcomere. 6 is sarcoplasmic reticulum. 7 is endomysium. 8 is triad. And 9 is myofibril. Do you need anything from sections A or B on page 183 repeated? Okay, let's go to section C, page 184. Sarcomere structure and the sliding filament mechanism of contraction. Number 1 is the A as in apple, A band. 2 is A band. 3 is M as in Mary, M line. 4, you should have had 2 things down. H as in Howard, the H zone, and the I band, the I band. 5 was I band. 6 is Z as in Zorro, Z disc. 7 is the H zone. 8 is the zone of overlap. 9 is sarcomere. And 10 is the H zone. Do you need any of that from section C repeated? Number 8 is the zone of overlap. Okay, moving to section D, the neuromuscular junction. Number 1 is synaptic vesicles. 2, the motor end plate. 3, the synaptic cleft. 4, the axon terminal. 5, the synaptic end bulbs. Okay, gang, let's go to using your knowledge on page 185. Okay, so the first question on page 185 under using your knowledge is meat from an older or younger animal more tender? Well, obviously, I think you know this, that meat from a younger animal tends to be much more tender. And the simple reason is because there is less connective tissue around the muscle. As all of us animals age, typically we develop more and more connective tissue, which makes our overall tissue tougher, firmer, less flexible. So number 1, meat from the younger animal is more tender because it has less connective tissue coverings. Number 2, weight training increases muscle fiber size by increasing the number of myofibrils. Explain. It's important that you appreciate that when you go to the gym and you lift weights to become stronger, generally speaking, you're not getting bigger muscles because you're making more cells. You're getting bigger muscles that are stronger because the muscle cells you already have are manufacturing additional myofibrils. The more myofibrils you have, the more forceful your muscle can contract. It's really that simple. The more myofibrils you have, the more forcefully your muscles can contract. Number 3 is control of the diaphragm voluntary, involuntary, or both? Well, the short answer is that it's both. We said in a lecture earlier today that you can stop your breathing for a little bit, which means the diaphragm is under voluntary control, but given enough time, your brain will override that and force you to breathe, which means your diaphragm can be placed under involuntary control in order to save your life. So the answer to 3 is both. Okay, number 4, 5, and 6. Number 4 is receptors on the motor end plate. Number 5 is receptors on the motor end plate. And number 6 is synaptic vesicles in the axon terminal. Number 6 is synaptic vesicles in the axon terminal. Folks, do you need anything from page 185 repeated at this time? Okay, let's continue with 7, 8, 9, and 10. 7 is smooth muscle. 8 is skeletal muscle. 9 is smooth muscle. And 10 is skeletal muscle. Okay. Do you need anything on page 185 repeated? Let's turn the page to page 186, where you have 3 photographs, and you were supposed to use numbers, 1 meaning least and 3 meaning greatest, to rank these pictures in their degree of cross bridge formation. The more cross bridges formed, the tighter, the shorter the sarcomere is going to be. So number 11 is completely contracted. So that's number 3 for greatest. Number 12 is most relaxed. It has the widest sarcomere, so that would be a number 1 for the least. And 13 is partially contracted. That's your middle one, so that's a number 2. The number 11 is 3. Number 12 is 1. Number 13 is 2. Folks, do you need anything repeated from exercise 12, lab exercise 12? Okay, not seeing anything. Let's go to lab exercise 14. For lab exercise 14, there was a great deal of work involved here, and I'm going to focus primarily on reviewing your knowledge at this point. We won't go over the using your knowledge because we also have to do the histology packet today. Okay, lab exercise 14. I know it was a great deal of work, so if you finished it and got through it, thank you for all your efforts. In the end, it will help you. Okay, page 233, reviewing your knowledge for exercise 14. Letter A, muscle compartment terms. Okay, number 1 is antagonist. Number 2 is fixator. 3 is synergist. 4 is agonist. Letter B, the criteria for naming muscles. Number 1, latissimus refers to the relative size of the muscle, and dorsi refers to the location of the muscle. Number 2, rectus refers to the orientation of the muscle fibers relative to the midline of the body, and abdominis refers to location. Number 3, trapezius refers to shape. Number 4, biceps refers to the number of origins, and brachii refers to location. Number 5, levator refers to action, and scapulae to location. Number 6, flexor refers to the action, carpi to the location, radialis indicates that this muscle moves to the radial surface, in other words, abduction. Number 7 is piriformis, which refers to the shape of the muscle. 8 is gluteus, which refers to the location, and medius refers to the relative size of the muscle. Number 9 is rhomboid. Rhomboid refers to the shape of the muscle, and major refers to the relative size of the muscle. Number 10 is pectoralis. That refers to location, and major refers to the relative size of the muscle. Gang, do you need anything from sections A or B repeated? Number 6. 6 is flexor, which refers to action, carpi, which is location, and radialis indicates that it moves to the radial surface. In other words, abduction is occurring. Anything else? Okay, let's start all the muscles on page 234, 235, because I know there's a lot of them here. Page 234, letter C, anatomy review. Number 1 is frontalis. 2, orbicularis. 3, omohyoid. 4, sternohyoid. 5, latissimus dorsi. 6, serratus anterior. 7, rectus abdominis. 8, external oblique. 9, extensor, carpi, radialis. Excuse me. Number 9 is extensor carpi radialis longus. Number 10, tensor fascia lati. Do you need any from 1 to 10 repeated? Okay. Moving to number 11, iliacus. 12 is the psoas major. 13 is the pectinus. 14, adductor longus. 15, sartorius. 16, adductor magnus. 17, gracilis. 18, vastus lateralis. 19, rectus femoris. And 20 is vastus medialis. Do you need any from 11 to 20 repeated? Okay, moving to 21. 21 is gastrocnemius. 22, soleus. 23 is flexor digitorum longus. 24, temporalis. 25, orbicularis oculi. 26, zygomaticus. 27, platysma. 28, sternocleidomastoid. 39, levator scapulae. And 30 is trapezius. Do you need any from 21 to 30 repeated? Okay. Continuing, number 31. 31 is deltoid. 32, pectoralis major. 33, brachialis. 34, biceps brachii. 35, triceps brachii. 36, extensor carpi radialis longus. 37, brachioradialis. 38, flexor digitorum superficialis. 39, palmaris longus. 40 is tibialis anterior. Okay, so 39, palmaris longus, 40, tibialis anterior. Do you need anything from 31 to 40 repeated? Okay, moving on. Number 41, fibularis longus. 42, occipitalis. 43, sternocleidomastoid. 44, trapezius. 45, deltoid. 46, triceps brachii. 47, extensor carpi radialis longus. 48, extensor carpi ulnaris. 49, flexor carpi ulnaris. And 50 is gastrocnemius. Gang, do you need anything from 41 to 50 repeated? Okay, moving on to 51. 51 is soleus. 52 is the calcaneal, also known as the Achilles tendon. 53 is frontalis. 54 is temporalis. 55 is masseter. 56 is platysma. 57 is infraspinatus. 58 is teres minor. 59 is teres major. 60 is latissimus dorsi. Do you need anything from 51 to 60 repeated? Okay, continuing. 61 is external oblique. 62, gluteus medius. 63 is flexor carpi ulnaris. 64 is palmaris longus. 65 is tensor fascia lati. 66 is gluteus maximus. 67 is vastus lateralis. 68 is gracilis. 69 is adductor, ADD, adductor magnus. 70 is semitendinosus. Let me finish this. 71 is biceps femoris. 72 is semimembranosus. 73 is fibularis longus, but you could also have peroneus longus for 73. 74 is soleus. Gang, do you need anything between 61 and 74 repeated? Number 70. 70 is semitendinosus. Anything else? Okay, gang, let's go to section D, page 236. Section D, muscles of the head and neck, numbers 1 through 7. Number 1 is G, zygomaticus major. 2 is C, orbicularis oris. 3 is B, orbicularis oculi. 4 and 5 are A, masseter, and E, temporalis. 6 is D, sternocleidomastoid, and 7 is F, trapezius. Moving to muscles of the anterior trunk. Number 8 is D, pectoralis major. Number 9 is A, deltoid. 10 is F, serratus anterior. 11 is E, rectus abdominis. 12 and 13 are B, external oblique, and C, internal oblique. 14 is G, transverse abdominis. Gang, do you need anything on page 236 repeated? Okay, let's go to muscles of the posterior trunk on page 237. Numbers 15 and 16 are C, latissimus dorsi, and D, teres major. 17 is A, deltoid. 18 is E, trapezius. 19 is B, erector spinae. Moving to muscles of the arm and forearm. 20 is J, triceps brachii. 21 is A, biceps brachii. 22 is B, brachialis. 23 is C, brachioradialis. 24 is G, flexor carpi radialis. 25 is H, flexor carpi ulnaris. 26 is I, palmaris longus. 27 is F, extensor digitorum. 28 is E, extensor carpi ulnaris. 29 is D, extensor carpi radialis. Gang, do you need anything between 15 and 29 repeated? Okay, let's continue. Muscles of the thigh. Number 30 is F, rectus femoris. 31, 32, and 33 are K, vastus intermedius, L, vastus lateralis, and M, vastus medialis. 34 is G, sartorius. 35 is E, gracilis. 36 is A, adductor magnus, longus, and brevis. 37 is C, gluteus maximus. 38 is J, tensor fasciae lati. 39 is D, gluteus maximus. 40, 41, 42 are B, biceps femoris, H, semimembranosus, and I, semitendinosus. Gang, do you need anything between 30 and 42 repeated? Okay, moving the muscles of the leg. 43 is B, fibularis longus. 44C, flexor digitorum longus. 45E, soleus. 46D, gastrocnemius. 47A, extensor digitorum longus. 48F, tibialis anterior. Okay, do you need anything on page 238 repeated? Okay. All right, gang, then let's shift gears and go to your histology packet. So go ahead and get your histology packet out. And I will do the same thing. And we will go page by page over the histology packet. Okay. In Monday's class, I wrote out the answers for the histology packet in the Word document. So if you need to review it from that perspective, you can go to the Monday recording and you will find it. For right now, I'll simply say the words to you so that you know what they are. Okay, page 1, letter A. Letter A, the bracket of letter A is trying to show you transitional epithelium. Bracket B is highlighting the connective tissue. Bracket B is connective tissue. Arrow C is pointing to kind of a little pink strip of material there. That's actually a collagen fiber. So C is collagen fiber. Arrow D is pointing to a fibroblast. Box E, when you look at box E, folks, you're looking at a blood vessel. That's what a blood vessel looks like. Letter F, all those arrows of letter F are highlighting the basement membrane, the transition zone between the epithelial tissue and the connective tissue. Gang, do you need any of page 1 repeated? Okay, let's go to page 2. Page 2, letter A. The bracket of letter A is trying to highlight ciliated, pseudostratified, columnar epithelium. Once again, letter A is ciliated, pseudostratified, columnar epithelium. Bracket B is connective tissue. Arrow C is a fibroblast. Arrow D is a collagen fiber. Arrow E is the basement membrane. Excuse me. Box F is around a goblet cell. And bracket G is around the cilia. It's around the cilia. Do you need anything repeated? Anything from page 2 you need again? Okay, let's go to page 3. Okay, on page 3, box A is around an individual simple cuboidal epithelial cell. Simple cuboidal epithelial cell. Box B is around an excretory duct, which is sometimes called an excretory tubule. So B is excretory duct or excretory tubule. Box C is in the center of the tubule, and that's simply the open space, which is the lumen. So C is the lumen, L-U-M-E-N, the lumen of the excretory duct. D is pointing to the nucleus of the cell, and E is pointing to the basement membrane. E is basement membrane. Do you need anything from page 3 repeated? Okay, let's go to page 4. Page 4, bracket A. Bracket A is hyaline cartilage. A is hyaline cartilage. Box B, that pink area is actually ground substance. You remember ground substance is one of the components of the extracellular matrix of connective tissue. B is ground substance. C is pointing to the nucleus of the chondrocyte, right? Cartilage cells are chondrocytes. So C is the nucleus of the cell, and D is pointing to the actual cell, which is the chondrocyte. C-H-O-N-D-R-O-C-Y-T-E, chondrocyte. E is box E is around the cavity or the pocket that the cell sits in. So E is the lacuna. E is lacuna. And F is the special membrane that you find around the cartilage called the perichondrium. The perichondrium. Do you need anything from page 4 repeated? Okay, let's go to page 5. Page 5, bracket A, this is adipose tissue. Box B is around individual cells, which are called adipocytes. C, once again, C is highlighting a blood vessel. And D is highlighting the nuclei of the adipocytes. You notice that in most textbooks, when you see a nucleus, it's always drawn sort of in the center of a cell, but there's no reason it has to be that way. Adipocytes have their nucleus smashed up against the inside surface of the plasma membrane. Okay, page 5, any questions? Okay, let's go to page 6. Page 6, bracket A is dense, irregular connective tissue. Box B is around the transverse section of a collagen fiber. Arrow C is around fibroblasts. And arrow D is pointing to the longitudinal section of a collagen fiber. Do you need anything repeated? Okay, let's go to page 7. Page 7, bracket A is showing you compact bone tissue. Box B is around an osteon. C, bracket C is trying to highlight those tiny little thread-like channels, which are called canaliculi. Canaliculi, very strange word. D shows you an arced arrow. D is trying to show you the rings of the osteon, which are called lamella. D is lamella. E, you could have said lacuna Or if you said osteocyte, the bone cell that's in the lacuna, that would be okay. Letter F is trying to highlight the internal structure of the osteon, which is the central canal. F is the central canal, sometimes called the Haversian canal. Do you need anything from page 7 repeated? Okay, let's go to page 8. Page 8. Bracket A is showing you skeletal muscle tissue. Bracket B is showing you an individual skeletal muscle cell, an individual skeletal muscle fiber. Arrow C is pointing out a nucleus. Arrows D and E are pointing out very tiny little structures that you really have to stare out carefully to be sure you understand things. D is a structure of the muscle cell called an A. A is an apple, A band. And E is an I band, the letter I band. And again, those stripes are due to the presence or absence of specific proteins that overlap with each other inside the muscle cell. Do you need any of page 8 repeated? Okay, let's go to page 9. For page 9, we have bracket A. This is showing you cardiac muscle tissue. Arrow B is pointing to a nucleus. Letter C is showing you the cardiac muscle cell. C is cardiac muscle cell. And D are the intercalated discs. Intercalated discs. You remember that intercalated discs have two special kinds of cell junctions with them, gap junctions and desmosomes. Once again, letter D on page 9 is intercalated disc. Do you need any of page 9 repeated? Okay, let's go to page 10. Page 10, bracket A, well, this is a picture of smooth muscle tissue. Smooth muscle tissue for A. B is highlighting the nucleus, and C is highlighting an individual smooth muscle cell. An individual smooth muscle cell. Okay, let's go to page 11. For page 11, we have bracket A. This is an example of areolar connective tissue. Box B is around a special kind of cell called a mast cell, M-A-S-T, mast cell. You may be aware that mast cells are one of the primary cells of the body that release histamine. Arrow C is pointing to the nucleus of the mast cell, and box D is around a fibroblast. Do you need anything from page 11 repeated? Okay, let's go to page 12. Page 12, bracket A, this is showing you reticular connective tissue. Reticular connective tissue. Box B is around a reticular cell. And the arrow of letter C pointing to those purple fibrous material, those are reticular fibers. Gang, do you need any from page 12 repeated? Okay, let's go to page 13. Okay, page 13, bracket A is simply pointing out what elastic connective tissue looks like. Elastic connective tissue. And then arrow B is pointing to those squiggly little purple lines that simply look like rubber bands, kind of. These are elastic lamellae. Elastic lamellae. Let's go to page 14. Page 14, bracket A is nervous system tissue. Box B is a neuron. Box C is highlighting the nucleus of the neuron. Arrow D is pointing to the nucleolus of the neuron. The nucleolus inside the nucleus of the neuron. Letter E are neuroglial cells. Gang, do you need any of page 14 repeated? Okay, let's go on to page 15. Page 15 may have been difficult because chapter 4 of your book really didn't have this in. So I understand if you didn't get it. But page 15 is showing you a comparison between an artery and a vein. Letter A for the box A is showing you what an artery looks like. Box B is showing you what a vein looks like. Bracket C is an area of the structure called the tunica media. Tunica media, that's the tunica media of the artery. Bracket D is the tunica interna of the artery. Bracket E is the tunica media of the vein. Tunica media of the vein. Bracket F is the tunica interna of the vein. Folks, do you need anything from page 15 repeated? Okay, hang in there, we're almost done. Let's go to page 16. Page 16, bracket A, well, obviously this is blood. Box B is around a erythrocyte, which is a red blood cell. C is a neutrophil, which is a type of white blood cell. D is a lymphocyte, which is also a type of white blood cell. And arrow E are highlighting those tiny little dots, which are actually blood platelets. E is platelets. Do you need anything from page 16 repeated? Okay, let's do the final page, page 17. Okay, folks, letter A on page 17 is lung tissue. You're looking at the inside of your lungs. Letter B is a tiny little structure there called an alveolus. Gang, the alveoluses, the alveoli plural, the alveolus is a gas exchange chamber. When oxygen goes into the lungs, it goes into each alveolus and crosses a structure that you really can't see on this picture called the respiratory membrane to get the oxygen into your bloodstream. Folks, the people that are passing away from coronavirus infection at this time, they may pass away for a variety of reasons, but one of the things that is killing people from coronavirus is that when you develop pneumonia in the lungs due to the presence of the virus, the alveoli that you see there, picture B, it fills up with liquid, and it's not supposed to fill up with liquid. It's supposed to stay empty with air. If it fills up with liquid because of the pneumonia, then the oxygen cannot get into the bloodstream and people slowly die from that. So this has relevance for the emergency that's impacting the world at this time. So letter B is alveolus, and C is a group of alveoli, which we call an alveolar sac. C is an alveolar sac. Pam asked the question, does that liquid have a name? Not really, Pam. The liquid is simply an accumulation of cells that have died, and when you have cells that die, they release their cytoplasmic content into the alveoli. So you could expect that a lot of the liquid is simply cell debris from dead cells. Okay, gang, do you need any from page 17 repeated? Okay. So I will open up the virtual floor to you at this time. Are there any other thoughts or concerns you may have? Brendan, you can stay online with me after others perhaps log out, and we can talk if you want. Do any of the rest of you have questions about content or anything you'd like to get some support on? One last thing before I forget is that I should give you a small quiz, a small practice quiz for the muscle exam coming up on Monday. So let's do that next. Just have a piece of scrap paper available, and I will show you 3 images of muscles that are going to show up on Monday's exam. So bear with me a second as I need to access the folder on my computer here, and I'll be with you in just a moment. Okay. All right, folks, I'm going to start sharing my screen with you. Okay, so we're going to do a small practice quiz, and I'm going to show you 3 images, and I will give you 40 seconds to figure out what each one of these is. Okay, here's our first one. Our first one, please identify, please name this muscle. Go ahead. Okay, that's 40 seconds. Let's go to the second practice question. Second practice question. Please name this muscle. There you go. Please name this muscle. Okay, that's 40 seconds. Let's go to the third practice question. Third practice question would be this one. Please name this muscle. Please name this muscle. And that's 40 seconds. Okay, folks, let's go back and review. Okay, so the first image I showed you was this one. Please type into the chat window if you know the answer to this muscle. What is this muscle? You know what it is? Okay, I hope I didn't stump all of you. All right, gang, this is the gracilis muscle. Gracilis, that's the first one I've shown you. Okay, let's go to the second one. The second one was this image. Can you tell me what this is? Go ahead and type it into the chat window if you know. Okay, let me tell you what this is. This is the flexor digitorum superficialis. Flexor digitorum superficialis. If this had you flummoxed, if this one gave you a problem, take a note where the tendons are. Notice how the tendons go into the fingers of the hand. That's very characteristic of this muscle and why I've highlighted it blue so you could pay attention to the tendons. All right, the third practice image. The third practice image was this one. Folks, if you know the answer to this, what is this muscle? Please type it into the chat window. Okay, Pam says fibulus tertius. Yeah, that's basically it, Pam. It's actually fibularis tertius. I mean, the spelling was a little bit off, but you have it. This is the fibularis tertius. Fibularis tertius. Okay, good job. All right, gang. So on your exam Monday, you log into the ClassMarker website with the account information that you hopefully have already established. You need your username and password, and you will be directed to take this exam. There are 35 questions. 29 of them are muscle identification questions, and 6 of them come from your histology packet. You will have 40 minutes to answer 35 questions. Do you have any questions at this time about the exam on Monday, about any content from lecture, anything that I can help you with? Okay, folks. All right. So it seems like everybody's staying basically quiet. So I'll ask you if you truly have no questions at this time, you can log out. Brendan, please stay on. We'll chat. And if you have problems or concerns that come up over the next day or two, send me an email and I will do my best to help you. Okay? So Monday, you have to take your lab exam. And of course, Monday at 8 a.m. we have our normal lecture time. So please be at lecture if you are able to. 8 a.m. we will have lecture, and then you have the rest of the day to take your lab exam. Folks, stay well. Take care of yourselves and your family during these challenging times.